Hello. Oh, is it okay? It will play video, right? Video. Okay. Morning, everybody. I think some of you were in. I don't know how many of you were there. Right, 3 weeks ago, right? When we were in, when you guys were in Hyderabad at Triple IT, right? So there I talked mostly about one project, iRaste, right? So I'll talk about that project. So some of you, it will be a repeat who are there, right? And also talk about some more stuff that we do as part of the INAI, right? The Applied AI Research Institute. So I'll give a little bit of background. I think you already got some background on my career so far. Right? So I work at Intel, been at Intel for the past 25 years. Right? So I graduated from SRKR, right, which is not too far away in Bhimavaram here. Right? After that, I did my masters and then joined Intel. So I've been in Intel for a long time, and over the past give me just a second. This needs to move. Okay, good. So over the past 5-6 years, right? Intel has been having conversations with the central government mostly, and a lot of state governments, and also the academia, right? In terms of using how we can do a better job of using AI. Right? AI has been a buzzword, right, for the past 5-6 years, and even your college completely transformed, right, from doing all the other courses to being AI centric, right. So what we wanted to do was, instead of everybody doing their own thing, the industry doing their own AI stuff, and then in the academia doing your own stuff, and the government doing their own stuff, we wanted to bring all these parties, three critical parties together: industry, government, and academia, under one umbrella, and use AI and other technologies to actually work on real solutions that will have an impact on the society. Right? So this is one thing that is always asked whenever you work on some technology, right? It's good that you can do some research, publish some papers, okay, develop some products, but ultimately, how is that helping society? So that's the goal here behind this Applied AI Institute that we got together with Triple IT Hyderabad and the government of Telangana, where we started this Applied AI Research Institute called INAI, where we wanted to use AI to actually solve some real problems. Right? So with that goal, we picked two domains. Right? One domain is healthcare, and the other domain is smart mobility. Right? Within these two domains, we wanted to do projects that will have actually, get deployed out there in the society and have a real impact. So under the smart mobility, we have multiple projects, and iRaste is one of our flagship projects. Also, I'll talk a lot more about that. But before I go into smart mobility, I'll talk a little bit on the healthcare projects. Right? And the reason we chose these two is because these are the ones which are most relevant for our country. Right? Healthcare, I don't need to explain to you, right? There's a lot more we can do in terms of improving our healthcare facilities. Right? And especially given that AI needs a lot of data to build these algorithms, right? And we have a big population and we have a lot of data available. Right? So if we can harness all that and actually use that to develop some solutions to solve our real problems and improve our healthcare efficiency, right, we'll go a long way. Right? So that's one reason to pick healthcare. And the second one, mobility. Again, the goal here is actually to reduce the number of road accidents that we have. So if you see the statistics out there, worldwide statistics, our country has the highest number of accidents and deaths compared to any other country in the world. Right? So our goal is, can we do something about it using this AI-related technologies to reduce those accidents? Right? So that's the reason we picked these two domains, healthcare and mobility. Right? And in terms of focus, right? Okay, you pick these two domains. How are you going to go about it? Right? So if you see healthcare, there's sort of three broad domains. Right? The first disease, right? But the ideal thing is that you do enough screening so that you catch the disease in the very early stage. Right? That's where you can have the biggest impact, right? Once you have the disease, it's really about disease management. Right? So if you can screen for something at the very early stage, right, then that's where you'll have the biggest impact. Right? So I'll talk about a couple of already have some sort of disease. Then how do you diagnose, and how do you diagnose it in a better way? Right? That's the second stage. The third stage is intervention. Okay, you already have the disease, now you need some sort of intervention plan, some sort of drugs. Right? I won't talk too much about the third vector because we're doing some good work, but it's still we haven't publicly talked about it. Right? Uh, all I'll say is, if you see how the drug discovery process happens today, right? From the time a company starts identifying a drug and the time it comes into the market, takes around typically 15 years. They spend billions of dollars to do that stuff. That has been what is happening over the past 50, 60 years in the drug discovery space. But if you see what's happening in the last 5, 6 years, there are almost like 200 to 300 startups in the drug discovery space, where they're able to do a lot of this pre-work in terms of how the molecules interact. So a lot of pre-work is how these drugs interact with your body. So you need to do a lot of this work. So with these new AI methods, companies are able to do a lot of this work in the simulation, and then actual wet lab where you take the drugs and test them. Right? That can be very. So this entire 15-year process now is getting squeezed to almost like 3 to 4 years. Right? So AI is having a really big impact in that domain. Right? In terms of genomics, right? The field is changing, where pretty soon you will get personalized medicine. Each one will have your own medicine because the medicine will be based on your genetic profile. Right? So I won't talk too much about it because that's too big a subject. Right? I'll talk about the other stuff. Okay. Then on the mobility side, the first one is road safety. Right? So that's where we have this project called IRAS there. I'll talk about that. Again, the goal is see if we can reduce accident and especially save lives. Right? That's the first one. Right? The second one is road experience, where we have a lot of solutions using this data and in terms of automatic identification of a lot of these parameters on the road, right? And also enforcement solutions, right? In terms of catching people violating, whether it is the no helmet, triple rider, a lot of these things, right? Now that you have a lot of cameras, using that data from the cameras, you can do a lot of this automatically. You don't need to sit manually and do any of this. And the third one, it's called IDD. I'll talk a little bit about it. It's short for Indian Driving Data Set. This is something we've been doing for almost 5, 6 years now, which is this data set is the data set of Indian driving conditions. So if you see all these algorithms that are being developed, especially for cars, a lot of the data sets out there are based on Europe and US conditions. There is no data set out there for Indian driving data conditions. So this is one of the first thing we did, where we equipped the car with bunch of sensors that drove all around India and actually have a good data set. Right. The last one is platforms. Actually, building platforms to capture the data and build autonomous driving solutions. So this is the entire different vectors that we work on at INAI, right? And I'll talk about projects specifically in each one of these. Okay, screening, right? So this is a very specific project, and if you see how our disease profile for the country has changed, say over the last 40, 50 years, since we got independence to where we are today. Earlier, the government's biggest concern used to be communicable diseases, right? TB, malaria, anything that is communicable. Right? We have come a long way where that is not a concern anymore, and now the non-communicable diseases are our biggest concern. If you see, go to the hospitals and see what is impacting cancer, cardiovascular diseases, and diabetes are our biggest concern right now. Most of the people are impacted by these things. Right? So in these, right, the particular one. So if you see chart on the right, that is showing various countries and oral cancer, incidence of oral cancer. Right? And you can imagine that big red spot out there. You know which country is that? Our country, right? So we have the biggest incidence of oral cancer in our country compared to anybody else out there. Uh, and the thing is, oral cancer, and a lot of it is due to tobacco use, but that's not the only reason. Right? The thing is, the oral cancer, from the time it starts to the time it becomes cancerous. So let's say something starts in your mouth. To the time it becomes cancer, it takes almost 10 years. So you have that long a time to actually detect it. So people have been neglecting for that long, right? So if you can catch it anywhere in that time, you can actually completely get it into remission. Right? So this is one of the reasons we selected this thing, where our solution right now is to take just a regular camera, right? And then we give it to the nurses or whoever is working in the clinic. They take around 5 to 6 pictures of the mouth, and then we develop the algorithms where the algorithms look at all those images and then see if the lesion is suspicious or not suspicious for cancer. So if we can develop such simple solutions and can deploy in any clinic out there, right, that will go a long way in terms of screening at the very primary healthcare center level. So that's the goal here. So right now our algorithm is at like 80 to 84% efficiency. So, and we have path to get to 90 to 95%. So when I say screening, this is the kind of stuff where we can have very simple solutions that using AI can be deployed at the very basic primary healthcare center level that can have a real impact out there and actually save lives. This is one of the partners we have. It's called the Grace Cancer Foundation. They have around 5 of these buses. Right? So they have the buses, and these buses do only one thing: cancer screening. So today they don't go out every day. The bus can go out every day. They don't go out because the doctor is not available. Right? So with a solution like this, they can go do all the screening, right? And then only the suspected cases the doctor can see later. Right? So that's the idea. There's a lot of infrastructure available, but the doctor is not available. So these AI-based solutions are really to help the nurses and the folks in the clinics to do something without the doctor being there. So the doctor can only look at the suspicious cases. So that's one. And the second one, we actually started a pathogen sequencing lab. So I think with the past 3-4 years, now everybody is familiar with the term variant, right? Because every 3 months there is a new COVID variant, right? So now we know what variants means, how viruses mutate and all that stuff. But this is how viruses were there for a long time. Nobody bothered until COVID came along. So if you see TB, for example, right, there are 23 different variants of TB, right? And a lot of them are also becoming drug resistant now. Right? The thing is, when somebody with TB goes to a doctor, the doctor doesn't know, and then he prescribes. So for TB, by the way, the doctor has to give a cocktail of drugs. They combine a lot of drugs depending on exactly what their variant is, but the doctor has to know what it is. So for the doctor to know, uh, right now they do lots of tests. They go do this test, go do that test, and it's an iterative process. And sometimes it takes a lot of time, and then you find out, oh, this is not this variant. Then you wasted 4 months, and then you start another cocktail. In the meantime, the people don't take those drugs, right? So there's a lot of issues. So if you can actually write on day one, you can sequence that genetic sequence and find out exactly which variant is it. Then the doctor can really prescribe the right medicine right there, right, and compress that entire cycle. So what we're trying to do here is come up with, if you want to sequence, right? For example, if you want to, this is about pathogens and bacteria. Today, if you want to do some genomic sequencing for humans, that costs 20 to 30,000 rupees. It's too high, right? So here we're trying to come up with methods where the sequencing will cost same as a blood test. Blood test is like 50, 60 rupees. So if you come up with a way where you can do the sequencing at the same cost as a blood test, then you can get to that level where you can exactly find out which variant of the virus you have and prescribe the exact medicine. Right? So ultimately, this I'm talking about pathogen sequencing. Ultimately, the plan is to really get down the human genomic sequencing cost to the point where you can really do personalized medicine. Right? Again, AI plays a big role because sequencing, you get a lot of data. When you sequence the genomic sequence a single genome, a lot of data. There's no way you can manually handle any of the data. So we absolutely need machine learning and AI to handle all this data. Right? So this is one another big area which can use all the machine learning and data learning. Okay, this one we're calling it Indian pathology data set. So I just talked about cancers, right? Uh, so the top 5 cancer cases, and they're only increasing every day. And you want to develop some algorithm, right? You want to develop some diagnosis algorithm and some algorithm for cancer in India. And you want to look at some data. So guess what? Most of the public data sets that are available out there are either based on US population or UK population or some other population. There is no really good data set for Indian population. And your algorithm is only as good as the data you feed into your algorithm. So you feed all the data for US and UK population. How would it give a good solution for Indian population, right? So the first thing you need is actually a good data set of Indian population for your algorithm to really come up with something that is pertinent to us. So that's what we're doing here. We're working with almost 3 or 4 hospitals where we're taking all that slides, pathology slides, and digitizing them and putting together this data set of Indian population. So after we do all this, we want to, by the way, everything we're doing, right, is will be open source. Right? We're funded by the government and Intel also under CSR initiative. Everything we're doing, all these data sets will be out there as an open source so that anybody can go and develop solutions based on it. So that's the fundamental principle here. Okay, so these are three examples. We have more projects, but the main message is whatever we're doing is either something that will have an immediate impact, like the screening solution I talked about, or developing a data set that is relevant for our population, right? So that people can develop solutions based on that. Right? That's on the healthcare side. I'll talk about the mobility side now. Again, the goal here, so I talked about 4 different things. The first thing is road safety. To see if we can use technology, not just technology, technology is one aspect, right? Technology, engineering, awareness, multiple vectors to reduce road accidents. So if you can see the names down there, we really have a consortium and each one brings their own strength to the table, right? So this is one more thing. If you're developing a solution that can really be deployed out there, right? It has a lot more factors, and you really need to put together a consortium where everybody brings their own strength, right? From Intel, we bring some devices. I'll talk about that, right? From INAI and IIIT, we bring the AI expertise, and then we have CRRI, which is the Central Road Research Institute. So there is a premier organization in the country. They know everything about the roads, right? Road engineering, and then we have Mahindra, who have been doing a lot of work in road safety. So Mahindra has been working on the Mumbai-Pune Express Highway, and over the past 8 years, they've been able to reduce the number of accidents on that road by 50%. It's a huge number. Right? So they bring a lot of expertise from their side. Right? So so how do we do this thing? So I'll show a video first, and then I'll talk about the specific aspects later. కొంచెం వాల్యూమ్ పెంచుతారా స్పీకర్లో కదా let me see. Might have to change the audio output. Give me just a second. I think that's all you'll hear. So I'll just play through, then I'll. Like you won't be able to hear the audio. So I tried all three. Yeah, that's what I first picked. Okay.
India has one of the largest road networks in the world and is emerging as the fastest growing network. With more vehicles on the road, safety is now crucial than ever before. To help address this, the Government of India is
Where is that coming from? Oh, we'll just put it in here. Okay, let's do that. Yeah. Oh yeah. Why don't we just
to achieve up to 50% decline in road accidents in Nagpur city.
I'll just use this. Oh, this fine. This fine.
India has one of the largest road networks in the world and is emerging as the fastest growing network. With more vehicles on the road, safety is now crucial than ever before. To help address this, the Government of India is aiming for a 50% reduction in road fatalities by 2025. In Nagpur, the geographical center of India, a pivotal project is taking shape. For the first time, artificial intelligence will act as a force multiplier and transform road safety engineering. Presenting iRaste, Intelligent Solutions for Road Safety through Technology and Engineering, a project that aims to achieve up to 50% decline in road accidents in Nagpur city. Project iRaste is a unique partnership of industry, academia and government and is initiated by Nagpur Municipal Corporation, CSIR, CRRI, Mahindra and Mahindra, INAI, IIIT Hyderabad and Intel. It brings in a holistic, safe systems approach to aspects of vehicle safety, mobility analysis and infrastructure safety. Advanced Driving Assistance Solution, or ADAS, will offer an economical way to enhance safety of fleets and road users. ADAS alerts, alongside driver assessments and training, can notably improve driver performance. Mobility analysis will monitor dynamic risks of the entire road network to define grey spots. Preventive maintenance of such risky stretches will prevent black spots before they claim lives. Infrastructure safety will design engineering fixes for existing road black spots. Continuous monitoring will also deliver improved ROI of road infrastructure maintenance. Join us in the mission to reimagine road safety with the predictive power of AI. Project iRaste, Intelligent Solutions for Road Safety through Technology and Engineering.
You're able to hear the audio. By the way, how many of you were there in Hyderabad session? You can raise your hands. Okay. Well, this will be a repeat for you, and maybe you can questions you can leave it to the others to ask. Right? You guys already asked a lot of questions when you're there. Right? Okay. So as you heard, right? So this is a new concept you are trying for the first time, right? Combining lots of different dimensions, right? And the three major vectors, right? The first thing is making the driver better, right? This is the vehicle safety vector, where we put a camera in the on the dashboard, right, on the screen, right. So this camera is looking at the road and doing real-time analysis of everything that's happening on the road, right? The all the vehicles that are moving in front of the bus, right? Whether any pedestrians are coming, right? So it gives four different types of warnings to the driver. Right? So this vector is about that warnings come 2 to 3 seconds before a potential accident can happen, and the driver has to take he has to take action, whether slow down or uh, stop completely or change the lane. So this is the first one where we equip the driver with this camera so that he gets advance warning of any potential accident. So this, by the way, this same camera, right, we use in other parts of the world to do completely autonomous driving. So we have 6 of this camera in cars uh, uh, to on all the 6 sides of the car, and the car completely drives on its own. So we have these cars running in Israel, New York, South Korea, lots of places. Right? But that's a long way away from in India, right? So we're not as disciplined as the traffic is over there, right? So here the focus is we'll use the exact same technology, the warnings to the driver, and the driver has to take action. Right? So that's the first one. Now, so okay, we made the driver better. We equip the driver with some technology, but it doesn't matter how good the driver is if the road geometry is bad. So that's the second aspect where we actually look at the road geometry. So this thing being in Nagpur, we looked at all the entire Nagpur network where these buses operate. Right? And we have this thing called black spot. Right? So I asked what a black spot was in that session, right? Lot of answers, right? So I won't repeat that. I'll just tell you. So black spot is a definition on the roads. This is by the Ministry of Road Transport and Highway, where they look at the data from the past 3 years, right? and based on the number of accidents, the number of deaths, they define a black spot. So when the government says something is a black spot, over the last 3 years, certain number of accidents have happened and certain number of people have died. So there can be multiple reasons why there's a black spot, right? The road is narrow or the footpath is narrow. There is some obstruction, right? So we went through all those things, and then there are around 38 black spots in Nagpur. So this is where CRRI, the Central Road Research Institute, has a lot of expertise in terms of all the remedial measures that needs to be taken in each of these black spots. So I'll show you one example. So this is the second one. The first one is you equip the driver with this AI-based camera to give them better warnings, right? The second one is fix actual black spots on the road, right, so that the infrastructure gets better. The third aspect is what we're calling gray spot. So this is a new concept where we have around 250 buses equipped in Nagpur, and they're generating data every day for us in terms of these warnings. We also get data if the driver is braking really fast and things like that, because this device is connected to the OBD port to monitor the speed of the vehicle, right, whether he's turning on his indicators or not. So we have a bunch of data, right? So this 250 buses getting data every day, this is a lot of data, right? So what do we do with it? So here the concept with the gray spot is, with all this data, can we do prediction of where the future black spots can be or will be, right? Because when something is a black spot, it's a trailing data, right? That means you're looking at what has happened over the past 3 years. Accidents have happened, people have died. Okay, yeah, I'll go fix the road to prevent future accidents, but if this is how you're going to do analysis, that means you have to wait for accidents to happen and people to die. But that's not right. Our whole point is to avoid that. And you have all this data. So here the goal is, using all this data that we're getting from the buses, we're trying to come up with a way to predict future black spots so that you can take simple measures and prevent the accidents from happening. I mean, that's the whole point, right? Now with all the data that we're getting from these things and all the AI tools at our disposal, right, can we come up with methods to prevent these accidents? So that's the third aspect. Right? I'll talk more about each one of these aspects. So this one, first one, this is the camera, right? So this is the camera which is on the mounted on the dashboard, which is looking outside, and then it has a very high precision GPS to see exactly where the bus is, and this is the indicator for the driver. This is like a small watch level device that is mounted on the screen, right? So that the driver gets two kinds of alerts, either a audio alert or the visual alert also, and he gets those four kinds of alerts that you see, right? The first one is a forward collision warning, right? If so the device is monitoring multiple things, right? The speed of the bus that is going, and based on the camera, it is looking at all the vehicles, almost like more than 180 degrees, maybe around 200 degrees. All the vehicles, not only vehicles, pedestrians, any moving object or even immovable object in front of it. It's doing real-time analysis of all this data. Based on that, it gives this warning: hey, there is, you, in 2 to 3 seconds, you might hit that bus based on how fast that bus is going and how fast you're going. It's a forward collision warning. The next one is pedestrian collision warning, right? If any pedestrian is coming, pedestrian or any moving object of that size, right? Even maybe a bicycle. And then the third one is headway monitoring warning. So headway monitoring warning is sort of related to forward collision warning, right? Here, based on your speed and the speed in front of you and speed of the vehicle in front of you, you're supposed to keep certain distance, right? If you don't keep that distance, and if you go too fast, then it becomes a headway collision warning, right? A forward collision warning. Otherwise, you need to, this warning is about, are you maintaining the proper distance or not? The fourth one is lane departure warning, where if you're changing lanes without using your indicator. So these are the four kinds of warnings the driver gets, right? And he's supposed to take action based on that. Right? So let's see. So this is so now the Nagpur project has been going on for almost 1 year. This is the data based on, say, the first 3 months of data. On the top right, you see, so this is a GIS map, right? The first thing we had to do was put a GIS map of all the road network and map everything onto it. So that's where all the buses are traveling within Nagpur. And then here you see the kind of alerts that we're getting, right? So the first thing you see is the headway monitoring warning, right? As you expect, Nagpur is this is an urban network, a dense network, right? So in a highway, probably they keep enough distance, but in a city, probably they don't keep enough distance, right? They're right against each other, right? And also you expect a lot of pedestrians in the thing. So the warnings reflect that. Now the thing is, okay, you have put these things. Now how do you measure the effectiveness? Right? You need to have some reference, right? You put these devices and the driver is supposed to take some action. How do you measure that? Any suggestions? Maybe let's see. Before I explain how we're trying to measure it, you put some new device and you need to measure the effectiveness of how this is working. Is the driver taking action or not? Anybody wants to? Actually, the folks who came there already know that, right? So maybe I'll move on. Maybe in the Q&A session we'll talk more, right? So the way we have gone about it is, so we put these devices, and for the first 1 month, we get all the alerts in the back end, right? But we don't turn it on, so the driver doesn't get the alert. We get it in the back end, right? So for every bus, for the first 1 month, we know how many alerts we're getting per driver. So that becomes our baseline because they're mostly going in the same route every day. For that route, for this guy, I'm getting this many alerts of this type, this many alerts of this type. So I have a baseline because he doesn't see the alerts, I see them, right? After that, for the second month, right, I turn on the alerts. Then the driver responds to the alerts, right? So whether he's taking action or not, or whether he's ignoring the device, then we'll know if the alerts have gone up or not. For example, if this month I got 100 alerts and the driver doesn't even know. Next month, if I get only 50 alerts, then I know that the driver is actually paying attention to them and actually taking action, right? If the alerts have gone up, that means he essentially is ignoring the device. Right? That means the driver is actually paying attention to the alerts and is changing his behavior to become a better driver. So what we've seen is, just like with any new device, technology is not just about, okay, I develop something, I'll put it out there and then see how it works. Until you work with the end user to really adopt your technology, it's not going to work. Especially something like this, where the driver is like, I'm driving my whole life, I know how to drive, who are you to tell me, right? So it's not easy, right? You might think, okay, I have some really nice gadget, right? It'll help you. But just because you think it's cool doesn't mean the guy will actually adopt it, right? So we had to spend a lot of time having a lot of training and awareness sessions with the driver to show all this and get them to use it. Even after that, the first 2 months is okay. But after that, it's a new device, we explain to them, maybe they'll adopt. It again tapers down. So every 2 months, we have to actually go and have sessions to really increase their awareness again and get them to adopt it. Right? So that's one thing we as engineers don't do much, right? We always think about technology and how cool can it be, how technically good it can be, but ultimately it's not about that. Those are all okay. Ultimately, you have to think about the end user. How easy is it, or how convincing can it be for the end user to adopt it? And they'll only adopt it if it makes their life, convince them. Right? Typically, when we're developing stuff, we don't think about all those things. Especially take my example, we at Intel, right? We used to develop the CPUs that go into the computers, right? And then somebody else is manufacturing the computers. So we bothered, right? But as we later found out, right, unless you know how the end user is using, right, you can't really, it gives a much better insights, right? Now we do a lot of end user research. We sit down with the people who are actually using the computers and see how you're using them, and then translate that into, based on that, my chip needs to do all those things, right? that gives a much better user experience to the end user. Similarly, for this also, right, or any device you do for that matter, not just in this domain, right? End user research is extremely important. Typically, as engineers, we don't do that. So you should really keep that in mind. Okay, okay, second one, infrastructure safety. As I talked about, right? Doesn't matter how good the driver is, if the road is bad, right? There's nothing he can do, right? So I'll just show you one video. So these are all the different black spots in Nagpur, right? By the way, to arrive at this thing, it took us a lot of time, right? Because we talked to a lot of stakeholders, the municipal corporation, the traffic department, the RTO. There are lots of stakeholders, the roads department, PWD, NHAI, National Highway Department. Everybody has their own list. Nobody talks to each other. So we had to talk to everybody, get all the data and digitize it and say, hey, there are some 120 combined list, but the real number of black spots is only this one. So we had to do this all the exercise and then actually come up with solutions. Right? Okay, what can you do? Right? So I'll show you one video of the kind of solutions that are proposed. There is no audio here, so that's okay. So the which one is the bottom that particular junction, and the top is the proposed all the improvements, remedial measures. And this again is the AI element, right? This is the first element. The AI part is already built into the camera, right? All the AI algorithms that were developed, or actually we made it into a chip, and the chip goes into the camera. It's already in the camera. But this part is actual data analysis, right? We get lots of data every day. Right? If you see there, right, those are sort of the hotspots that we came up with based on all this analysis of all this data. Again, and we're still revising this thing, come up with our own formula. So this is one thing that it's a typical problem you'll have in any of the projects you're doing in AI. Right? You have a lot of variables, right? And then you're trying to make sense of all these variables. Which one is important, right? And that's a big task, right? So here we're taking all this. In this case, if you see the equation at the top, right? Here the attempt alerts, right? The pedestrian collision alerts, forward collision alerts, and give them certain weightage. And then we're also taking the road geometry, right? You see N3 arm, N4 arm, right? It's a combination of all these things, and this is where we have to do a lot of analysis. Right? Which one gives us the best data? Right? So, and this will be same for any problem you take, right? You'll have too many variables, right? Which ones to consider, and out of the ones you consider, how much weightage you give, right? This is a very iterative process. And then ultimately you come up with something, then you have to do ground truthing. We came up with 20 spots. Now, how do you know? You're trying to predict something. You can't really have a way to check. Right? We actually go on the ground and see these spots. Right? The algorithm is predicting that these will be future black spots. How is the actual ground situation? So this is not there's no straightforward method, and there's no easy way when you're trying to do something like this. So this is an iterative process, right? So we're still going through that. So this is a GIS database we had to put together, right? So this didn't exist before. The entire road network, and we have all the FIRs for all the accidents for the past 3 months, not 3 months, 3 years in Nagpur. Digitize that entire data and put it on this map. So if you pick up any black spot, we know exactly how many accidents happened, how they happened. Right? This is another level of analysis, right? To see what exactly is happening, the root causes. Okay, that's Nagpur, right? I'll skip this. I already talked about all these things, right? Okay, then the next one we're doing is Airasti Telangana. So in our country, 50% of the accidents, half of them happen on the highways. and those highways constitute only actually 5% of the roads. Right? So 5% of our road network constitutes 50% of the accidents. So the focus in Telangana is, so this was launched in July, to really focus on the highways. Right? So we picked two highways, Hyderabad, Vijayawada and Hyderabad, Bangalore, right? The two most densely used highways. And we working with TSRTC and we installed around 100 of the buses that ply on that network. So it's mostly the same three kinds of analysis that I talked about in Nagpur. We'll do similar stuff. But we added one more element into this thing to get even more better insights, right? So this is the where the buses go, by the way, right? It's mostly the Hyderabad, Vijayawada, and Hyderabad, Bangalore. There is something else also. Right? Mostly that's what we focus on for our analysis. I don't think anything comes to Kakinada. Maybe Samui Court. I don't see. Anyway, we don't do the analysis for that network, right? Only until Vijayawada we do the network, we do the analysis, right? Okay. So one additional element in this thing is a driver monitoring system. So this is a camera that is on the dashboard that's looking at the driver. Right? So for all the stuff I talked about is looking at the uh, scene in front of the driver on the road. Right? So this one actually looks at the driver for these 5 different things. Right? These algorithms have taken a long time to evolve and they're really good. Whether it is smoking on the phone or not wearing the seat belt. I think those 3 things are okay, right? If the camera is looking at you, the algorithms to do those 3 things, they've been developed for a long time. It's the last 2 that are really the tough ones, right? This is where AI plays a big role. So the 4th one is if he's sleepy, right? So for that you need to do a lot of analysis to essentially track the his eyes and at what rate he's closing them, right? So to determine whether it is he's just blinking or whether he's droopy, right? That takes a lot of data and a lot of effort, right? So that's one thing. And the last one is if he's distracted, as in if he's looking somewhere else instead of looking straight. That's also a little bit difficult, but not as tough, right? The camera is looking, if it's looking straight or looking here or looking here. So these 2 things also we track, right? So we have 2 sets of data, right? One is the road conditions, how is the road condition, and for these buses we also have the driver condition. So again, a lot of data, we need to combine all this and see what measures we can do. So this is an additional element for the Telangana. Right? So some of the early analysis that we have done for the Telangana, like this I already talked about, right? This is the network. Right? And by the way, this talks about the black spots. I just talked about the black spots for Nagpur. If you see, so this is the Hyderabad, Vijayawada, and these dots you see are all the black spots in the Hyderabad Vijayawada highway. And then the blue spots you see here are on the Hyderabad Bangalore highway. So we have around 48 here and around 60, around 110 black spots. A lot of black spots. Again, we have to do similar analysis and see what are the remedial measures. So one example of the early data from Hyderabad, for example, if you see this graph, right? This is combining 2 kinds of alerts, right? So this is for the month of September and October, right? Here we're combining 2 kinds of alerts, a headway monitoring HMW alert and LEW alert. LEW means lane departure. The driver is turning into the other lane without using his indicator. And then after that you got a headway monitoring alert where the distance between the bus in front of you and you is too low. So we're combining these alerts to see if they're coming almost at the same time. That's what's happening is the driver is taking a big turn and then going very close to the bus in front of him. So very high chance we'll have an accident, right? So these are kind of analysis we're doing of all this combination. And here you see where that is happening, right? On the highway, if you see all these these blue spots, that is where most of the drivers are engaging in that kind of behavior. And then we also, because we also take the driver roster data and map it. So we also know exactly which driver is doing it. So we feed all this information back to the depots, and then we give every month the top 5 and the bottom 5. So the depot manager for the top 5 drivers, they get some incentives. The bottom 5 drivers, they get to go to the classes. So this is a constant reinforcement we'll have to do, right? Because you got to have some incentive, right? The drivers who are doing good, they're like, okay, I'm doing better with this device. What am I getting? Right? You got to have some incentives. Technology is all fine. At the end of the day, you have to do something more than that. So we're going to do a lot more analysis. Similar thing for Nagpur too. Okay, that's IRAS. Then I'll talk about a few other projects, then we'll open up for questions. I talk about road infrastructure and enforcement solutions. So here the plan is to actually take simple cameras, put them on the car and collect the data, or not collect the data, or have algorithms that can do automatically a lot of things that the police or other people do manually. For example, pothole detection. So this one is not easy, but this is completely automatable. So we actually put one camera on the car, and then the car goes out, and you can get exact pothole map of where exactly the pothole is. That we have already done, but now we're trying to also do the depth of the pothole, how big is the pothole, and things like that. Right? So this, what you see, is the outer ring road. So I know this traveled over the last 2 days, right? Bhimvaram here, right? I've been traveling here, right? The question is, the government will want to do something once you give this data. Otherwise, what's the point, right? So at least for this outer ring road, there the government actually cares because it's one of the highly used thing. So they want this thing immediately so that they can take action. And we can do this in a completely automated way because there is a lot of patrol vehicles on the going around this road, and we just put a camera and this thing is generated every day automatically, right? So this is one thing. Second thing is tree counting. Again, there's a lot of emphasis on planting trees and greenery, green cover, right? Again, taking Hyderabad as an example, right? They did a lot of work over the past 9 months. The question is, how many of those trees are alive, right? How are we doing, right? Again, sometimes somebody goes and checks something and writes in a register, right? Again, this can be completely automated. We just put a camera, the camera looks at everything and then counts all the trees. We can tell exactly this area is where all the trees survive, this area is where trees didn't survive. The same thing we do for other stuff, by the way, right? In terms of, I didn't show it here. We are working with GHMC right now, where in terms of the cleanliness of a given street, right? Of where to every day morning, where should I send my crew to clean the roads, right? And also the lights, right? It's also very easy to do. Where first of all, we count all the light poles automatically, or in the night you can see which lights are not working, so that they know where to send the folks to replace the bulbs. A lot of this can be completely automated, right? Using this AI and data science. The second one. Some folks may not like it. This is more of enforcement solutions. So work with the traffic police, right? They actually, so they have a lot of CC cameras. So right now we're not working with that feed because that is not as clean, right? The CC camera feed is not as clean. So right now these examples that I've shown you, these are based on camera just based on the car, right? So if you see this thing, right? So this has two solutions implemented in there. This can do both triple riding and also helmet violations. So if you see this guy, right? No helmet, no helmet, no helmets, and triple rider, right? So this can be done really good, right? By the way, it's not easy because there are a lot of false violations. You only need to look at people who are riding a bike, not somebody who is walking without a helmet. So there's a lot of false positives that come on. So the algorithm needs to take care of all those things, right? And also the driving conditions, right? It's easy to do when the weather is really good, but when folks want to deploy a solution, they want to deploy for any weather, right? It can't only be good weather. So there's a lot of work that needs to be done for an algorithm to really make it robust. So we have some of these solutions that we're working with the enforcement folks. Then IDD, right? So I talked about this is a data set that we've been working almost for 5-6 years now. So if anybody wants to work with Indian driving data conditions, right, this is there are other ones right now, but this is the biggest data set that is available out there. Right? And the latest one, so this is all the number of users and all that stuff. Right? By the way, mobility doesn't mean just the cars on the road. As we learned, once we put this data set out there, uh, we have seen a lot of other folks who want to use this data set. Right? For example, we have, of course, people who want to work on the mobility on the road work on this. This data set right now we have around 8,000 users around the world. Right? One user, for example, is a robot manufacturer in Japan. Right? They make robots for senior citizens at home. Right? So the robot needs to work with the right senior citizens, right, your grandfather or grandmother, and further to work properly, it needs a data set where anything can come from any side, really unstructured conditions. What better than our road set, right? Where anything come from any side, right? So they've been really using this data set to train their robots to become much better, right? So there are a lot of these other use cases. An example, you see these vacuums. I think the Roomba is one of the company. The automated vacuums where you leave it there and it cleans the floor, right? So those guys are also using this data set where the machine can have a lot of unstructured conditions, right? That needs to get trained for, right? So we continue to do this. The latest one we have is what you call in IDD 3D. So far all our data sets have been using only camera so far. But it's the first time we have multiple cameras and we also have a LiDAR, right? LiDAR will give you three-dimensional thing like radar. So that is also added into the data set, right? So this gives you a much more granular data, right, to deal with, right? But it also makes your analysis and your algorithm also a lot more complicated, right? So a lot more stuff you have to do to dealing with images. The algorithms and the AI stuff has been there for a long time. It's pretty mature. Now you want to deal with new kind of data, lidar data, radar data, and other things, and also the night vision data. Then you'll have to come up with new methods to deal with all this data. And the last thing I'll talk about is the platform, right? So you need some platform to collect all this data, right? So this IDD data set, we used to get a car, put some cameras, collect the data, right? And then again, the car goes away. So now we have built a platform. So this we use it, but anybody else can also use it, where it has a lot of cameras on this car, and then it also has a lidar on the top, and also it has a lot of processing power in the car itself, computers. So we use it for ourselves, but the reason we build this is for anybody, right? Any company wants to develop some new algorithms, or even you guys want to develop some new algorithms. But you need a data set that doesn't exist today, right? What you can do is you can use a platform like this. It already has a bunch of cameras and all those things. You can put a new kind of camera, and then you can collect your own data so that you don't need to build your own car and all that stuff. For example, say you want to develop some algorithm that looks at all this camera and also monitors the driver's physiological parameters. So you can add some sensors, right? On top of all the sensors that are on the car, put some sensors on the driver and then collect that data also. And the combination of all these, you can do this analysis. So there are various things. If you want to do some new stuff, then you can use this vehicle and add your own sensors and do it. That's the whole idea behind this thing. Again, for GHMC, they wanted to run this for a few roads in Hyderabad. So they used this car, ran this for 2-3 days, collected all the data they wanted to collect, and then they put out a big challenge where something like I think almost 100 startups came in. It was open to anybody. I don't know if any of you are aware. This ran for the last 1 month, right? It is open to anybody to come participate. Right? They give you this set of data, and then you have to right, predict all the potholes. Right? The best algorithm gets 15 lakhs. Right? So things like that. Right? That's the first challenge we ran. Okay, one last thing I'll talk about, and I'll finish this and we'll open up for questions. Right? So this is also one project we're doing. One of the professors at at IIIT. He's been working on this for the past 20 years. Right? He works with the National Disaster Management Agency. So he has two applications. The first one is called Rapid Visual Survey. Right? This is for people. NDMA is the National Disaster Management Agency. They are the first responders to any big calamities in the country, floods, earthquakes, and all that stuff. Right? So those guys, when they go somewhere, especially earthquakes, this is for earthquakes. I mean, you see these kinds of houses. The thing they need most is to know whether that structure is safe enough to go inside or not, because they need to rescue somebody, right? And most of the times, based on their experience, they make determination. Okay, based on experience, I know this is good or not, right? But what you're trying to use is again here use AI, right? Where we're trying to collect as much information as possible of the kinds of houses that are impacted and create a database, and then build an application based on all this data, where we will give this application to the first responder. He goes there and then he clicks the picture, and this AI algorithm will tell him based on all the learnings that we have, yeah, you can go this or not, so that he doesn't need to rely on his experience or somebody else's judgment to go inside the house. So that's one, right? Again, our goal is to actually use technology that's actually deployable and make an impact on the ground, right? So we pick this up because this can make a real difference, right? And then the second one is something called Earthquake Disaster Risk Index. So they have this EDRI indices they developed for entire country, right? For example, especially the municipalities, right? In a municipality, they can do this assessment for the entire municipality, go to every house and say, this is a risk index. And they have a bunch of parameters. Again, what we're trying to do is develop a solution based on a drone image. Right? So the municipality guy will go with this application and a drone. Will deploy the drone. The drone will look at the entire, say, building. They want to assess a building. Based on that image, we'll say this is the risk index, earthquake risk index for this building. They want to do a lot more, whether that's according to the norms or not. Right? So that's a different thing. Right? Norms is a different thing, but here it's about earthquake stuff. So this because it will have a real impact on the ground. Right? So, okay, guys, that's the last one, right? So I'll open it up for questions. There were a lot last time, so don't be shy. So if anybody have any questions, you can ask. Any questions? Yeah. You can give the mic.
Morning, sir.
Morning. Right.
Sir, how can a driver can usually take a decision within 2 to 3 seconds? Second.
Yeah, good question. Right. So a lot of research went into this thing, right? Like you're giving a warning to a driver. What is the optimal way to go about it, right? Uh, so Intel bought this company called Mobileye, right? And they've been working on this stuff for almost 15 years now, right? So we have done a lot of work where we sort of varied this time, right, from 1 second to almost 5 seconds, right? Thing is, if it's 1 second, typically these things, by the way, this technology only kicks into action once you cross like 20 to 30 kilometers per hour, because less than that, you don't really need this, right? So you're going at 60 to 70 kilometers per hour, right? Typically, or highways 120 plus 100, right? So there is that speed, right? And then so there's 1 second is too less, and if you 5 seconds is too much, right? Then you get too many warnings. Then it's not useful. So we did lot of research, and then we after all that the outcome was 2 to 3 seconds is the optimal time where the driver has enough time to respond, and also it's actually useful, right? It's actually a real alert. Right?
Any more questions?
So by the way, one more thing. So these algorithms, right? Again, talking of India, right? Originally, these algorithms were developed. Mobileye worked on all the data sets from US and UK. That's what their target market was. To deploy this in India, right? So they did a lot of work here where they put these cameras and then went all over India for 3 years, right? Because you have a lot of conditions that you don't see out there, right? Here you have people coming and say stop, right? They're not going to see that anywhere else in the world, right? And they'll just cross the road, right? So they had to customize their algorithms for India, right? And they actually have a real deployment out there. If you buy the Mahindra XUV 700, the same camera that's we are using is in the Mahindra XUV 700. So if any of you guys have it, right, or drive in it, so you can turn on the ADAS feature and you'll get the same alerts. You'll see it. So you can then judge how good or bad it is, right? Whether the 2 3 seconds is good enough or not. Right?
You have a question?
Good morning, sir. I'm Bhavana from CSM. Actually, I want to notice, give you notice to you that actually during the drive when with my father, I listened a song, sensor song. It was warning a belt, a seat belt. It warning the driver to have the seat belt. I asked my father that what's that song. Then he said it is the seat belt sensor. It is warning. Then he set the car to the roadside and set the seat belt backside. Then the sensor automatically stopped. What actually my father didn't put the seatbelt, sir. But he set the seatbelt to backward, then it stopped working. And it stopped giving the warning. What I'm trying to say is not just my father, like so many people feel irritated to keep the seatbelt or some other warnings what the sensor gives us. What I'm trying to ask you is, you said we will set of one sensors to the car. So what they just do is they just give warnings. So what I'm trying give the idea is that can we choose a better way than the sensor?
We can choose a better way. By the way, so what did you advise your father when he did that?
I said
Did you ask him to actually really wear the seatbelt?
yes, sir, he won.
He wore it. Okay, that's good, right? See, we can have a better way of giving the information to the driver, right? But fundamentally, it comes to compliance, right? If the person doesn't want to do it, right, then it doesn't matter how much information you give the person, right? Then it doesn't really matter, right? It ultimately comes to technology is technology, right? It is giving you something. If you don't want to use it, doesn't matter how nicely I give it to you. So it comes to that. That's the reason we do a lot of work on awareness, right? We sit down with the drivers every 3 months. We have a awareness session with them, and then also have incentives for them, right? And also like these gray spots I talked about, right? In some of the gray spots, we work with NGOs to go to all the colonies around the gray spots, and we do a lot of awareness sessions. Uh, some people listen, some people don't. It's not easy, right? Ultimately, if people don't want to use the technology, not much we can do. Right? I mean, I see when I go in taxis, right? The drivers, if you sit in the front, some of the cars, the passenger also has to wear. So they already have a, right? You have to wear the thing, that clip that they have. They already disconnected the clip. Let's say just put in the clip in the thing, the sensor will stop. Right? That's completely defeating the purpose, right? But then again, it's up to the driver.
Any questions?
పెట్టొచ్చు బైక్స్ మీద ఏం చేస్తారు చెప్పు బైక్స్ మీద పెట్టొచ్చు యా we can give the same thing can go on the bike. By the way, our target is mostly fleets right now, essentially four wheelers, buses, a lot of lorry fleets, right? And then cars, right? We had some discussions on the bikes, and actually we also have not only this, some other technologies where the driver will get some indication on the bike. At least so far our thought process is, the problem with the two wheelers is not technology. Actually అందరూ హెల్మెట్ పెట్టుకుంటే యాక్చువల్లీ మనకి 75% యాక్సిడెంట్స్ తగ్గిపోతాయి. మోస్ట్ ఆఫ్ ద డెత్స్ ఆర్ బికాస్ పీపుల్ డోంట్ wear helmet, head hits the ground, right? They die within 5 minutes, right? Because of the bleeding, right? Bleeding is the number one problem of death, right? So it's, before we get to technology, I think first people need to do other things, at least with the two wheelers. Yeah, right now the way we have designed it is, it's dependent on the driver, right? Like I said, the same technology we are using it elsewhere to do completely autonomous driving, right? So నాకు దీంట్లో ఉన్నాయి, I can break the bus, can you, nobody else around has this thing, right? So if I, without the driver's involvement, if this device stops the bus, that might actually lead to more accidents actually, right? So unless you have everybody else also using the same technology, right, you don't want to get into a state where somebody else other than the driver is making the decisions for the vehicle. So as of now, it's dependent on the driver. And also legally kuda it's a problem, right? I can't do that in India right now. Is it? కరెక్టే, కానీ ఎంత బ్రేక్ వేయాలి, సడన్గా ఆగిపోవాలా, కొంచెం స్లో చేయాలా, ఐ మీన్ ఇట్స్ ఎ స్పెక్ట్రమ్ ఆఫ్ డెసిషన్స్, ఇట్స్ నాట్ వన్ సింపుల్ డెసిషన్, రైట్? అది డివైస్ చేసిందనుకో, ఎవర్ రెస్పాన్సిబిలిటీ, సంథింగ్ హ్యాపెన్, రైట్? దెన్ హూ విల్ టేక్ లయబిలిటీ? డ్రైవర్, ఏ అది చేసింది నేనేం చేయలేదు అంటాడు. దెన్ వాట్? it's giving an easy way out to the driver. The goal is to change the driver behavior, make them a better driver. So as of now, we are still keeping it in the driver domain. So if you see the autonomous driving thing right now, right, there are levels, right? L0, L1, L2, L4, where L4 is completely autonomous, right? And some of these Teslas and other things, they're doing it L3 plus L4, right? దాంట్లో L0 is where it's driver assistance. L1 you can automate some other things, but that's a very tricky situation, right? L0 is very easy. You give the stuff and the driver takes a decision. L4 is completely autonomous, where everything is autonomous. Majorly, it's not easy to define, especially on the liability. If the machine is doing some things, the driver is doing some things, who does what, and something happens, who takes the liability? A lot of questions there. Nighttime also. It has to work during both, right? Yeah. To the extent that it can, right? In the sense, if the bus is not completely visible, that's a different thing. But generally, there are the tail lights. You'll see the bus. Right? Completely dark ante, if there is no light and if you have the thing is not at all visible in the camera, it's very tough, right? But even if a little bit visibility is there, right, then it will work, right? So far, nighttime complaints are rather, right? I mean, this technology has been in the works for 15 years, right? It's a lot. So the chip that is in there is a fifth generation chip. So it has gone through a lot of stuff, right? So it's generally pretty robust for night and day conditions. Because like I said, the same thing is deployed in a fully autonomous mode. It works in other countries. Take New York for example, right? New York, it's been running for the past 1 year, where the traffic is as bad as in India, right? Right? It's pretty bad in New York, right? It is able to handle that. And New York has a complete spectrum of conditions, right? And not only day and night, summer, winter, snowy weather, all kinds of weather, rainy weather. It's been running okay so far. If it can handle all that, whether it can handle, it's the indiscipline of the drivers that's a bigger problem for us. Actually, it's not supposed to, but anyway, they do. Yeah. Yeah.
So that we have the deadlock conditions. Actually, deadlock conditions will occur at any time. We don't know when it will happen. It is weak. If the system will be deadlocked, how it will. If the accident will happen.
Correct. And those things have happened in the US also. Right?
So how can you prevent it?
We can't, in the sense, we can only minimize it. And if you're seeing like the number of accidents over the past 4 or 5 years, right? There are some 3 or 4 high profile cases because people want to talk about it. But if you see the proportion of the number of Tesla cars, I'll take Tesla, since you talked about Tesla, there are other cars too. The number of Tesla cars out there and the number of kilometers that they cover, and proportionately the number of accidents that have happened, it's very less actually. It won't be zero. It will be, some accidents will happen. It's just a continuous learning process. Right? That's the only way, because whatever accidents have happened, if you read the analysis of every accident, there were some extreme corner cases where the algorithm couldn't see something or it came too fast, right? Conditions that normally don't exist. You'll always have exceptions. You just need to minimize the exception, it won't be zero. But in this case, because there is life involved, right? Yeah, the bar is very high.
Any more questions?
Good morning, sir. Actually, you said that it has an option like ice cream.
Ah.
So, is it possible to have face recognition like the emotion of the person? Maybe in the car he will smoke or not, but if he is already drunk and he can drive the car, so there are chances. And in most of the cases, the accidents occur in the night time. Already the person may drunk and drive the car. So, I think it's better to include the face recognition or the complete detection of the face rather than the ice cream. So, is it possible to include that?
Face is easy actually. If you see the current state of affairs, face recognition algorithms are pretty mature. Right? So we can easily include that, right? Again, it's a question of the end customer and what the product is trying to do, right? In this case, that's one aspect, because these guys, they know which driver will go into which car, because there are I think in some cars where they have the ID recognition and the car won't even start until the driver is recognized to be only these set of people can drive this car. We can easily do that, but in the customer base that we're targeting, they didn't ask for it. So we can add that if they want. Right? Again, because that requires more work. Right now, my system is independent. If I have to do that kind of thing, then I have to connect this to the ignition system, a lot more work. That's one thing. On the drunk driving part, a lot of them already do the alcohol test, right? Since they are already doing it, this is more for when the driver is driving, is he getting sleepy? If he is drunk, he should not even be sitting in that seat, first of all. Right? So that people typically do. If it's CSRTC, they do their test, right? They're not relying on us. I think what this will do is, if he's getting sleepy when he's driving, right? That they don't have any way to test, right? So that's what this is.
So, in most cases, in some rare cases, they may become the serious cases sometimes. Of course, the government is doing their best, but it's my question, like, is there any specialty or it can do the work if the person is already drunk?
We can. So, see, the good thing is, once you install the camera, a lot of these things we can just do a firmware or a software upgrade. Right? So what I have shown you is what is deployed today and what we're testing. Right? Again, based on the feedback, right, we can add more things like you just said. Right? So we will go through that process. And again, one more thing, right? We will have to see. Generally, there are drunk driving solutions, but again, this particular one, drunk Indians are different from drunk Americans, right? So we need to get a lot of pictures of drunk Indians, right? So we'll have to go through that process, right? And then drunk drivers, right? It's a different thing, right? Yeah. Go ahead.
Sir, if both the cars are coming in the opposite direction, is it possible for the sensor to detect both the cars?
If the sensor can detect that, that thing is inbuilt, but right now that is not a condition we're tracking in this study, right? This is mostly it tracks all the vehicle in front, right? For the use cases we're looking at, it's not that big a problem in the sense, typically, and mostly it's two-wheelers coming on the left, right? Cars and buses on the highways coming opposite, it's very less. Yeah, maybe you'll have tractors coming in the opposite direction, right? The system can do it, but right now we're not tracking that as part of this study right now.
And in the many snowy places like Delhi, it is not possible to see the cars and the bikes which are coming and which are going. Then is it possible for the sensor to detect?
To the like in foggy conditions, you mean? Yeah. As long as the camera, the camera is pretty good. As long as something is visible in the camera and the algorithm can see that there is some vehicle in front, the algorithm will work. But if the visibility is really bad, right, that you can't even see the vehicle in front of it.
And many of the accidents take place at that time only, sir.
Correct. The algorithm, if it can't see in the camera, it won't work. The thing is, if the visibility is that bad, that vehicle should not be driving. He should stop on the side. Right? Yeah. So yeah, right now it's camera based. If you actually put a lidar or a radar based, then we also. But again, the cost will be so expensive, right? The whole point is making it a low cost solution that you can put on any car or a bus. A simple solution. Right now we import this whole thing. It costs around 30 to 35,000 rupees. We're trying to manufacture it locally to bring it really down. To handle all those kinds of conditions, I need to put a lidar or a radar. It will be lakhs of rupees. Nobody will buy it, right? So technology is one thing, like I said. Again, you have to look at the end customer. How much is he willing to pay? What use cases is he willing to pay? You take all these considerations to deploy a real product out there.
And many of the people, if the camera is in front of the car, will they prefer to buy that car?
So depends on how you design it, right? In the sense, what we're doing right now is an aftermarket, and our for me as part of INAI, my goal is to really show the efficiency of this technology, right? The same thing, there are other people within Intel who are trying to sell this to end customers. Their targets are this bus fleet and this truck fleet. They are okay to put a camera, right? They don't care about the look and feel. But if it has to go into a camera and a consumer is buying it, then it has to look nice. There, for example, we work with Mahindra, and Mahindra has this completely integrated. You don't even know that there is a camera inside.
Sir, you said they work on sensors. But if there is any network issue, there is any alternate way to fix.
So the sensor is completely local. All the alerts that the driver gets, the camera and the chip are doing all that, and he gets it. That has no dependency on any network. So there is a 3G SIM. All the alerts go to the central server, but that's for me to do analysis later. Whatever the driver gets is completely local. There is no dependency on any network. There's no questions on any of the other stuff. I thought maybe the healthcare stuff. I think will actually make a much bigger impact, right? If anybody has any questions on healthcare and what you feel about that, you should ask about that also. Go ahead.
Yes, sir, you may know some of the expensive accidents are done while climbing a hill. So, this vehicle camera can detect while climbing a hill, this can analyze the way and it may dangerous. It can
Generally, yes. I don't think we have that steep climbs where the angle is so bad that you don't even see in front, right? And also, when it's climbing a hill, the speed is also not that bad, right? Generally, we haven't heard any issues from customers so far. Right? The camera is able to see.
and about rapid visual survey is that survey is able to detect when the activity come the buildings are collapsed.
Right.
But we were training to model damages images only. But nowadays, the application coming cannot say which type of buildings are being collapsed.
So yeah, so the the work they have done so far, they have categorized buildings into 7 different categories. All the buildings in India, right? So in each category, generally any building can be put in that 7 categories. In each category, we'll need. So that's one thing, right? So it's not too many classes, only 7 classes, and then in each class we need to have enough data to say, and also we need the ground truth. That's very important for this application, right? So right now we're telling the people who already deal with it, whenever you go, you take a picture, and then you also need to tell me the ground truth for that picture, right? Because the algorithm needs to know the ground truth to really predict good prediction. Right? So this will take some time because it's not easy to get that kind of data.
One more thing that is, you said that while driving, that device can capture what it's a living trees, it can copy trees. So it can able to detect that while driving the tree is being to be fallen, it can detect that
The IRAS project, or the other projects. In in IRAS project, whether it's a tree or anything like a pedestrian, if a pedestrian is coming, right, then it will detect. Actually, I think I've shown this in other ones. I have the Nagpur alerts, how the alerts happen in Nagpur. Give me just a second, I'll show those alerts. Right, then I think they'll give a better picture. So this is videos of actual alerts in Nagpur. Oh, sorry. It's a new laptop. It didn't. They're all on OneDrive. Okay, never mind. They're not on the local thing. Sorry, your question was. No, last question. Yeah.
while driving,
Oh, for she's fine, right? Yeah. So as long as anything is in the view of the camera, it poses a danger to the vehicle. Tree ante, I don't know about tree. Tree falling, that's a just when the bus is about the tree falling, I don't know. Right? I'll have to ask my team to see if they simulated that situation. Right? Typically, it's some pedestrian or some other vehicle, something else coming, suddenly cutting across and things like that. That are more common, right? So, Avani, they simulate all those things, right?
Sir, already we have artificial intelligence technology. So we are using the technology like Tesla cars and Leica Sophia. So and the automatic vacuum cleaner also, sir.
Mm.
So and we also we are using Internet of Things in automatic vacuum cleaner and Leica Sophia, sir. Sir, is there is artificial intelligence.
Well, definitely. So, for AI, what is the most important thing? For any AI solution, what is the most important thing you need?
Automation. That is
Not automation. Huh?
internet.
Not internet. For any AI algorithm, what is the primary thing you need? You need data. And where do you get the data from?
Internet.
Not internet, but if you see a lot of the things, a lot of this IoT stuff is essentially sensors sitting somewhere, right? So a lot of the data comes from the sensor sending all the data, right? So they're intricately involved, right? Without all the data, you can't develop these algorithms, right? But again, it's a actually if you see the statistics, because the number of IoT devices essentially exploded quite a bit, right, in the last 5 6 years. Uh, One statistic from last year, 98% of the data that's generated, nobody does anything. Because if we're generating so much data, it's just sitting there. Right? Only 2% of data is actually analyzed. Right? Uh, so, uh, so we definitely need data, and the IoT devices are generating the data. Right? But the more and more, what people are trying to do is move that intelligence right to the edge, where at the edge itself, the IoT device will collect the data, and there is some intelligence, right? Some sort of small processor, AI processor, or normal processor that will do the analysis right there and take the decisions right there. Because sending it all to a central server, somebody has to analyze the data, and it's terabytes and terabytes of data. So there's a lot of scope, by the way, in that aspect, right? Making AI algorithms work at the edge with very minimal resources. Right? You can't put a big CPU or a server on the edge. Right? So that's going to be a big focus in the coming years. You can develop the algorithm, but you want to make it such a small footprint, so it needs to work with very minimal resources. For example, this oral cancer thing I'm talking about, right? Right now, the algorithm that we developed for that oral cancer screening, it works on the CPU. We're still trying to get it to work on the phone, so that I don't need to deploy a computer in the clinic. So there's still a lot of work that needs to be done in that area to make them really efficient to work on smaller devices.
As per my observation, we just developed the sensor algorithm based on our previous data sets, like number of black spots or gray spots of the particles. But it is in India, as you know, that the dimensions are completely changed every time. Based on the climate changes, the number of particles will increase. So it is becoming a challenge to develop the algorithm again and keeping an eye on the road path, on the old road path again, and being analyzed in very complex sites. So
Yeah, so right now, so the two aspects to your question, right? First aspect is, at least for this iRaster project, right, the data we're relying on doesn't change that much, because the data I'm relying on, first data is actually all the alert data from the buses. that is completely in my control. All this black spot stuff, black spots don't change that much. If you see our black spot map, that's right, because they are there for a reason. There is some issue with that spot, right? But all the other data does change, right? But for IRASTE, we're not using it. But whether it is pothole detection or tree detection or a light pole detection or something else, right? Right now, the algorithms you're developing as really to sort of do this continuously. We're not making any decisions. It's really to monitor continuously and help make them decisions. For example, this Hyderabad Municipal Corporation, the plan is to put these cameras on their vehicles that go around the city. So once we do that, once we develop the algorithms, we will get data every things. Yeah, they'll change every day, right?
Answer. My question is that we are implementing and many projects regarding to save our lives. But what is about animals? Nowadays, many accidents are also animals are dying because of accidents.
Well, if the accidents reduce, that part also will reduce, right? I mean, in this case, for example, when I say pedestrians, right? If an animal, depending on the size, if it's a small dog, maybe the camera might not be able to. If it's on the highway, if it's a big animal, then they'll get the alert, right? But in general, the goal is to reduce the accidents. If we reduce it, then more animals will be saved as well, right?
Recently, our relatives met with Yuvagal sister, as they said that they spent lot of money for the scans rather than the treatment, sir. I heard that screening is a process of detecting it before in additional stage. They said that it's been too long for detecting it, sir. As it was treated for since 6 months, it means. I'm just personally suggest that I just wanna build a sensor of screens or at a public place or any personal cause detecting the tuberculosis or any disease COVID in this person, which is additionally should be detected. Is this possible, sir?
Yeah, actually, we don't even need new sensors, right? For example, there are a lot of companies which are trying to do this TB screening just based on the cough, right? While you phone the screening, you can just cough into that, and based on that analysis of that, they're trying to see, right? So even before we try to get into new sensors, right? Companies are trying to come up with solution using existing devices that we already carry with us, right? That's one aspect, but that's going on. That'll take time. Thing is, development is one aspect, right? The bigger problem is deployment, right? When we develop చేస్తున్నాను, right? I spend equal amount of time talking to partners to actually deploy it. And also the whole point of this institute, establishing this institute, is to bring the government and the academia and industry under one umbrella, so that after we develop, we actually have a path to deployment. Otherwise, what's the point, right? And that's been a typical problem, right? Industry, we care about money. In academia, folks care about publications and other things, right? Government don't know what they care about, right? Everybody has their own thing, right? Unless we work together, it won't go to deployment, right? For example, this thing, this oral cancer thing, right? I'm coming from Bhimavaram, so I went to VDC, right? Vishnu Dental Clinic, right? They have around 35 remote clinics all over AP, right? I really want this app deployed in all their remote clinics, right? So that everybody who comes to that clinic gets screened, right? Until we go do that, right? And that's where most of our failures have been. Technology development to a certain extent, a lot of people are doing, but getting into deployment has been the tougher part. With TV Code, there are a lot of solutions, a lot of companies, right? Getting it to the primary healthcare center and actually getting somebody to use this regularly has been a bigger issue than actually developing the technology. Healthcare law, that's a big problem. variants, they don't change that much, right? Okay, I think now with COVID, because of the way it is, you're getting new variants. But if you see all the other diseases, TB for example, we have around 23 variants, and the virus doesn't mutate that much that you every 2 years you get a new variant. అంత లేదు. The challenge right now is the doctor doesn't know which variant it is until you do a battery of tests, and by the time he goes through that, right, 3-4 months, and you find out it's a wrong variant, you already wasted 3 months giving a wrong cocktail. The patient gets disillusioned. Course ఉంటుంది. You have to finish that course. Lot of people don't finish that course, and that creates additional problem because you take half the course, stop, the bacteria becomes drug resistant. So you're actually making the problem worse, right? So if you can find out on day one exactly what is that variant, right, with a simple test, and prescribe exactly what the patient is needed, that will help a lot of problems. The patient will also see progress immediately. He'll actually finish the course, and the doctor also doesn't need to go through trial and error. But for other things, COVID is an exception, right? But generally for other things, the variants are pretty settled, right? You don't get new variants that fast. You just need to detect what variant it is. Yeah. Performing operation అంటే ఇది, I mean, whatever we're doing is only, we're not, అసలు my surgery side వెళ్ళట్లేదు. This is only for initial screening, right? Somebody comes, you need to know what kind of disease he has or what kind of variant he has, right? What we're doing is completely non-invasive, right? Surgery is a whole different thing, right? We're not going there at all.
Any questions? I have a question, sir.
Yeah.
So while developing a project, what are the basic steps that we need to follow? Like what is the back end and what is the idea that we need to initiate while developing a project, or while we get an idea to develop a project?
Who is we? You or
For example,
students?
take students as a team.
Okay. See, I mean, there's multiple dimensions, right? For me right now, so I'm in my role, right, is to actually develop applications that can be deployed and have a real impact on the society, right? I also have wear my Intel hat. If I was doing something in the company, right, I have a totally different set of criteria, right? It needs to be commercially viable. My end customer is willing to pay for this or not, right? Totally different criteria, right? In my case, right, I'm looking at stuff that is deployable, right? Commercial criteria is not a thing. I guess in your case, right, maybe for these projects also we're looking to get some interns to work on some of these projects, right? Especially IRASTE and even some of the other things, right? But so putting this aside, right, in general, if you are looking at projects, right, I think you will have your technical criteria anyway, right? But what I would suggest to you is do also think about the end deployment, right? That way you can actually have, because ultimately when you go into a job, right, whatever you do is actually driven by end deployment, right? So the sooner you start having that mindset, I think the better it will be for you, so that you're not doing something just to show a demo and be done with it, right? Whatever you're developing, think about a couple of steps ahead, beyond the technical parameters of this can do this. What can I do more so that this is actually useful, right? So it will make you think about actually how the end user will use this, right? As I was saying in the beginning, right? Typically, what happens is you develop some core stuff, and for the deployment, there's a lot of things around it that you need to put, whether it's the user experience or how it is integrated into other components, right? When you go to go to a job, that's actually more important. A lot of the stuff is about integration, not core deployment. When you go to a company already has some components. Most of the projects that are about integrating all these components and putting together a full-fledged solution. Right? So that typically we don't think about, or at least get into that mindset earlier right now. It will probably mean a little bit more work for you, but it'll put you a step ahead, right? And get you ready for the real stuff that you need to do when you go out there into a job.
Yeah, putting everything aside, talking about core stuff, only the technical criteria. So there will be two things. The first thing is domain knowledge, and the second is the programming knowledge that you should have. So based on your views, which thing is more important, domain knowledge or programming?
Well, both are equally important, but in your situation, it's tough to get domain knowledge, right? Even right now, for me, for example, I have 6 partners. Why do I have 6 partners? Because most of the people I work with, engineers and students, they all have technical knowledge. They don't have domain knowledge. So I go work with people, CRRI and Mahindra, who actually have on-field expertise, right? So do the best you can and learn how much ever you can. And like working on projects, real projects like this will expose you more to the domain side.
We too are waiting for an opportunity to work for these kind of projects, hopefully.
Hopefully soon, right? Srinivas Garu will follow up with you.
Any more questions? Does anybody have any questions?
Sir, from screening to intervention and social mobility, you always talk about prevention. Is there any remedies for it if something wrong happens?
Prevention, can you repeat the last part?
You always speak about preventions and safety measures. Is there any remedies if something wrong happens? You can detect before.
Wrong happens as in?
Yes, sir.
Yeah. Well, yeah, remedy as in, for example, again taking IRASTE, right? We're doing all this stuff, right? But we're also working with an NGO. They actually do a lot of work at the black spots, right? I mean, we try to do all these things, but still accidents happen. Then what do you do, right? And most of the people die in accidents. The number one reason for people dying in accidents is loss of blood, right? Because accident happens, and then some injury happens, they start losing blood, and they die because of that more than anything else. So what this NGO is doing, for example, in Nagpur, is all these 38 spots. They work with the people around the black spots, the all the shops around it, the puncture wala, whoever is around the black spots, they train them and they give them first aid kits, right? So that when if accident has happened, you can do nothing about it. Try to save the person by attending to that person in the first 1 hour, called the golden hour, and stop the bleeding. If you can stop the bleeding, most of the time you can save the person. Right? So there are things like that we're doing too, but there's nothing to do with technology. That's general stuff just to save lives. We'll wrap it up.
Thank you very much, sir. I hope our students, some of the students happy to be you being here, and some of the students, I think, most of the students are related to sir's new technologies, real world industry, what's going on, development, everything he has given. I asked your mental health. Introducing AI in health is very, very important, and most of us, why we conducted this session is you have to enlighten your people around you when you go to your village or somewhere. You have to tell these technologies extending to discuss and everything. And we thank you for coming over here for giving so much of information. real-time projects happening. So best websites. They are searching some websites, but after searching some time, they don't know what they are searching. Because too many websites will come and disturb our thought process. So if you can give those really workful websites so that they work on it and they see how the technology is going to next level and how the projects are there, just for getting the knowledge of students.
Sure, I don't have a ready list, but I can talk to my staff and my students. They probably have a good list of things, whether it's the data sets or other things that they go through. I can ask them to put together a thing and send that to you.
Why? Because we are doing foundation for modern machine learning program. Around 350 students are doing, sir.
Yeah.
So where what we are doing is they're sending some lab sessions and we are doing that. But they can't do in a live data set. Just they're clearing the doubt. They are visualizing and most of the students are doing what is the steps we have to take, what the step is going on in these lab sessions and they're clearing some questionnaire part only. But the students are not up to the mark of doing their own.
So in FMML, I'm sure a lot of you are taking that, right? How many of you are taking the FMML? Okay. So what data sets you, my colleague handles that, so maybe I should know this, but I don't know. What data sets you guys use?
Cancer data set, IRIS data set.
Okay. Okay. Then.
All data sets only, sir.
Okay. Then I'll talk to them, right? I'll work with them and see what they're already using and see on top of it any other references that we can
They
send.
were introduced, sir.
Ah.
How to recognize the word to word, something like that. So I'm guiding the students. So I'm getting that we have to train in such a way that they have to do one and get them down their own, so that they have an idea what this process is happening. And they are giving the project also, sir. You once go through it, you can get an idea of all those things.
I'll talk to them. I think, but one thing you guys should take advantage of, right? Compared to when I went to college, right? 25 years ago, right? You guys have so much more available, right? That we never had, right? In terms of all the, first of all, information, right? In terms of the exposure and all these online courses, there is so much more that you do that you can do on your own. Okay, the college will teach what the college will teach you, but on your own you can do so much, right? I think you guys should really take advantage of that, right? You have it available, so you should take advantage, right? So I would urge you guys all to do that, right? And also in terms of this Kaggle data sets and all the other stuff on online courses, right? I will send the list, but you yourself, you should be able to do a lot, right? And you should take advantage of that.
And we are very happy, sir. For long day you came here to us to advantage for our students. And we hope that you will come again and again. And you can accept, you can activate to remote place also. Communicating once in a week with our students.
Sure, we'll figure out some plan, right?
Yeah.
We'll first close on the interns for the thing once we get going, right? Yeah.
Very happy, sir.
Thank you.
On behalf of high power institutions, I'm very thankful for accepting our request
No problem, sir.
to give regarding policies with respect to our students. Thank you.
Sure. Sure. I will talk to them down there.
Sir, we want to finish this.
Hey, felicitation ఏముందండి? బొకే ఇచ్చారు కదా చాలు.
సార్ మరి ఇప్పుడు యాక్సిడెంట్స్
I think she just wants to.
As you said, the project, as it is an open source project, how can we as students work on those projects?
Yeah, so this IRASTE is, the data set is still not open source, right? Open source as in we're not publicly publishing it yet because the project is still active, right? So it will be accessible to the people who are working on the project and whoever interns, right? But there are other data sets. IDD is completely open set, right? That has been.
This is not, but commonly, how open source, how can we as students work on those projects?
You should be able to, like, if you go to Kaggle, there's lots of data sets that those are completely accessible to you, right? There is no restrictions. If you want to develop algorithms, you should be able to. I don't think there's any restrictions. You'll have access, right? I mean, I'll have to check on specific data sets. Some are completely open. Some come with some restrictions, as in you'll have to put in a request and put your problem statement, and then they'll approve. So there are multiple levels of access. Some are completely open, right?
We need to send a request to them and they need to approve it and we
Some of them, but some of them are completely open. You can just download and work on it, right? So that's what I'll ask my staff and students to sort of put together maybe a top 10 something like that. Then you can, then so that you don't have to go do a lot of searching on which one is which, right? I'll do that. ఎందుకండి ఇది?
A small felicitation from our side.
అయ్యో